Hello viewers, this video presentation is for the topic Normalization from the second unit of Database Management Systems. And the objectives of studying this topic is to describe the need of normalization and to convert the relations into 1NF, 2NF and 3NF normalized forms. Let us see about the normalization. Normalization is the process of organizing the data in the database. It is used to minimize the redundancy from a relation or a set of relations. And also it is used to eliminate the undesirable characteristics like insertion anomalies, updation anomalies and deletion anomalies. So, in normalization, it divides the larger table into smaller table and links them using relationship. So, the normal form is used to reduce the unwanted characteristics and to reduce the redundancy from the database table. Types of normal forms. The first one is first normal form. It will be shortly called as 1NF. A relation will be 1NF if it contains an atomic value for the attributes. It states that an attribute of a table should have atomic value. It should not have multiple values. It must only have single valued attributes. So, first normal form disallows the multi-valued attribute, composite attributes and their combinations. So, for a relation, to satisfy the first normalization, it should have a single value for all the columns. Now, let us see one example. Employee table. This employee table is not in a 1NF form because the attribute employee phone number having multiple values for an entity. For example, John having 2 contact numbers. Also another one person Sam having 2 contact numbers. So here one attribute is multi-valued attribute. So this relation is not in a first normal form. Now we are going to rearrange the table to satisfy the first normalization form. So we have to rearrange the table like this. We have added necessary records, necessary rows to maintain the additional multiple values for the particular column for the entities. Like we are created one more row for the John, for the person employee John, and in the another new row we have added this additional phone number like John, first phone number, and other attributes will have the same value like employee ID, employee name and employee state. And to reproduce the multiple values of that particular employee phone number, we have created the additional rows. So in this manner we have recreated the table. So now this table have satisfied the first normalized form. Also for the Sam, we have created one more row to keep the additional phone number. So the number of rows have been increased in the normalized table. Next one is second normal form, shortly called as 2NF. So in a 2NF, a relation to satisfy the 2NF form, second normal form, at first it should be in a 1 normal form. In the second normal form, all non-key attributes are fully functional dependent on the primary key. This is the condition to hold the 2NF form. So the condition is all the non-key attributes should be fully functionally dependent on the primary key. Let us create the table for the subject. The subject table is having 2 attributes, subject ID and the subject name. And here the subject ID will be the primary key. And also we are considering another one table to store the score details of the students, score table. And the score table is having the attributes score ID, student ID, subject ID, marks and teacher. Now let us see. We can identify the marks scored by the particular student and we have to understand The student with the same ID having the undergoing multiple subjects and the marks for the multiple subjects are displayed in this particular table. For example, the student with the ID number 10 is undergoing two subject ID, subject number 1 and subject number 2, and from the previous table we can understand that the subject ID 1 belongs to the subject Java and the subject ID 2 belongs to the subject C++. So the particular student with the student ID 10 have scored 70 marks for the Java subject, 75 marks for the C++ subject, and also having one more attribute, teacher. So for the subject ID 1 is handled by Java teacher since it is the subject Java, and the subject ID 2 is handled by the C++ teacher. We can identify the subject ID 2 belongs to the subject C++. So now we are going to consider the teacher attribute, and before that, in the score table, the combined attributes of student ID and subject ID will be the candidate key, which is also the primary key. That is the combined attributes, that is the composite attributes, student ID along with the subject ID, both combinedly only will become the primary key. Since previously we told a single student is undergoing multiple subject. So both combined attribute only will become the primary key. So the student ID and the subject ID is the primary key of this particular table. Now only we are going to identify where the problem is. The problem is with the attribute teacher. Now the teacher is dependent on the subject ID, not on the student ID. Isn't it? The teacher is dependent on the subject ID, not on the student ID. So here the condition with the second normal form is all other attribute in a table should be fully functionally dependent on the primary key. But here the problem is the teacher attribute is not fully functionally dependent on the primary key. It is only dependent on the subject ID, not the student ID. So the teacher attribute is partially dependent on the primary key. Since the primary key is both student ID and subject ID, but the teacher is not dependent on both the attributes. Teacher is not dependent on student ID. Teacher is only dependent on the partial attribute of the primary key, that is the subject ID. So this leads to partial dependency on the primary key. So this will not be allowed for the second normalized form. So to eliminate this partial dependency, we are going to rearrange the table. So initially we are going to add this particular attribute, teacher attribute, to the first table, that is subject table. So subject table will have the attributes like, after rearrangement, the subject table will have the attributes like subject ID, subject name and teacher, and the score table will be having the attributes, and then we are eliminating the teacher attribute from the score table. Now the score table will have the attributes like score ID, student ID, subject ID and marks. Now we have satisfying the properties for the second normalization. So now these two tables have satisfied the second normalized form. Okay. Now we can move to the third normal form, 3NF. So for a relation to satisfy the 3NF, first it should satisfy the 2NF form. And another one important condition is, it should not contain any transitive partial dependency. The attributes of a table should not contain any transitive partial dependency. This is the condition for third normal form. So 3NF is used to reduce the data duplication. It is also used to achieve the data integrity. So that relation is in 3NF. It holds at least one of the following conditions for every non-trivial FD. X implies Y. X is a super key. Y is a prime attribute. That is, each element of Y is part of some candidate key. So here the condition is the attribute should not contain any transitive partial dependency on other attribute. So here we are going to consider the employee detail table. Employee detail table having the details like employee ID, employee name, employee zip code, employee state and employee city. So here the super key in the table may be employee ID, comma employee name, employee ID, employee name, employee zip and so on. So here the employee ID will act as the candidate key. The employee ID it is used to uniquely identify the employee, so it will act as the candidate key. And the employee non-prime attributes are here all the attributes except the employee ID are non-prime attributes. And here the problem is employee state. Now we can see the employee state and employee city is dependent on employee zip code. Okay, employee state and employee city are dependent on the employee zip code, and employee zip code is dependent on the employee ID. Here the problem is the employee state and employee city are not directly dependent on the employee ID. In turn, employee state and employee city are dependent on the employee zip, and employee zip is dependent on the employee ID. So then these non-prime attributes employee state and employee city transitively dependent on the this employee state and employee city transitively dependent on the super key employee ID. This violates the rule for the third normalized form. Okay, the employee state and the employee city is transitively dependent on the super key employee ID. This violates the third normal form. So to make it to satisfy the third normal form, we are again going to decomposing the table. We are going to decompose the table into two tables. The first table can be called as employee table. In the employee table, we can keep the attributes like employee ID, employee name and employee zip code. And that second table we are keeping. The second table may be called as employee zip table. In the employee zip table, we can place the attributes employee zip code, employee state and employee city. Now we can avoid the problem with third normalization. Now this decomposed tables have satisfied the features of third normal form. Next one feature of the decomposition is dependency preserving. It is the important constraint of the database. Here in dependency preservation, at least one decomposed table must satisfy every dependency. That is, if a relation is decomposed into two relations, that is, if a relation R is decomposed into relation R1 and R2, then the dependencies of present in R must either be present in R1 or R2, or it must be derivable from the combination of functional dependencies are R1 and R2. So in this feature we are telling that assume one functional dependency is present in one table. So after we are decomposing the table into two tables. Here the thing is that dependency should be present in the decomposed table. It should not be lost. The dependency should not be lost. The dependency should be maintained in any of the decomposed table. That we are calling as dependency preserving. Suppose that the relation R having four attributes A, B, C, D with functional dependency, A implies BC. A implies BC is one of the functional dependency present in the relation R, table R. And we are decomposing the table R into R1. R1 is keeping three attributes A, B, C, and R2. R2 is keeping two attributes A and D. which is dependency preserving because the functional dependency A implies B is now present in the relation R1. So the original dependency is preserving in the one of the decomposed relation R1. So this is called as dependency preserving. So when we are doing the decomposition, the dependency should be preserved, that should be concentrated. Okay. So up to this we have studied about the first normal form, second normal form, in third normal form, and we can see the remaining normalization forms in the upcoming videos. And the only one possible university question is explain 1NF, 2NF and 3NF with proper examples. So thank you all.